electricity. Okay, it's a new unit 10. I hope you work with me and you don't miss a lesson. We'll start look about several things actually about the define of static electricity, electric current, and how charged particles interact with one another. Textbook starting our lesson 484 and your homework like usual find it on Classera. If we start, you know what is the building unit of this tower? Of course, we have the famous one, Khalifa Tower, the highest building in the whole world. Okay, but what is the building unit, the smallest unit for this tower? How they started it? You think about it. So I think most of you will think this Mr. started floor by floor, okay, till they finish it to the end, to the last floor, to make the highest or the tallest building in the whole world. So actually, if I just take the simplest unit or building unit of this tower, I'll find, yes, surprise, a simple brick. So everything that, whatever its size, it must end with a very simple unit. That's something that must be very small at the end, like a brick for using for building our houses. So if I change my question, what is the smallest thing for any matter? Or asking about the smallest unit or the building unit of any matter at all. Remember when we talk about states of matter, when we always try to draw the particles of the matter as circles and try to understand how they get far from each other, gaining more energy between solids and liquids and gas. We always say we have the matter consists of small particles, okay? We have to update our information. This particle, we will call it today the atom. This particle, we will call it today the atom. So everything around us is made of atoms, even the gases or the air, cars, buildings, smokes, gases, even us, our bodies at the end, fruits, anything we eat? Actually, yes. Our answer is yes. So my answer will be yes for all of them. Everything consists of atoms. If I jump to the atom, what is atom? It's too small. We need a special microscope to see it. And a surprise for you that even the atom consists of smaller particles. So even it has a smaller particles inside. In the atom, the core or the heart, or in the middle, what we call it nucleus. Nucleus is the area where I have two particles. The blue one, or we color it in blue, of course it's not real blue, we call it protons. Protons. While the red one we have inside the nucleus beside protons are neutrons. The left one around that's spinning around so fast, running, we call it electrons. So I have three till now. First one, protons. Two, neutrons. And three, electrons. Both protons and neutrons inside or inner region or area, what we call it nucleus. So let's talk about them more. Each one of them have electric charge. Electric charge means a property of a particle that affects how it behaves around other particles. In an easy way or easier way to understand electric charge, it means about the electricity inside the battery. If you look closer, you will find that electric charge have signs of positive and negative. So electric charge means one of two. The first one, you see it very famous on your battery, that's positive, and on the other side the negative one. That's meaning of electric charge in very easy way, positive or negative. If I like to describe it, I'll say how you will behave. You will have a positive or you have it as a negative. So don't let the new concept of electric charge and the long word scare you off. No, it's easy. In a very easy way, in two words, positive or negative. Protons, from its name, I will take the first P. So I would say protons positive. So P with P, too easy to remember. Okay, electrons, the opposite, are negative. So this one positive, that one negative. What about the middle, neutrons? The word in neutrons, it means I am neutral. What that's supposed to mean? Neutral means no charge. I don't have any charge. So the protons, I can make a symbol positive above it to remember, while the electrons are the opposite, running around. I will not stay beside you. Okay, I am negative. While neutrons, nothing. I will draw nothing. They are neutral or means no charge. Let's jump one more step. So again, to confirm our information till now, protons, P with P like I said, we will say here positive. Electrons, we will say the opposite, negative, like you see here, negative and positive for protons. And last one, neutrons. It's mean neutral or no charge. That's why here, if you look to them, you will see no colors or no signs at all, not positive nor negative. So that's our three important particles inside the atom itself. Number one, protons again. Two, electrons. Three, neutrons. Can you help me to remember their names again? So I said the negative one, we call it, yes, electrons. Two, both together in an area in the middle, we call it, yes, nucleus. Three, the positive one, we say P with P, positive means protons, yes. Last one, four, the one with no sign at all. It has nothing, no sign, no charge. It's neutral, so we will call it neutrons. Excellent. Let's try to count these atoms. I think that each atom has same number of protons and electrons. Okay, so let's try. I have one electron here, two, three. So I have three electrons. What about the middle, the protons? Protons for the red particles here, or red circles or spheres. So I have here one, two, three. So I have three protons. So they are equal. Yes, it's right. So let's see here again, if the positive charge or protons are equal to the negative charge, it means electrons. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 negative charges or 9 electrons. What about the positive one, the protons? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 positive charges. They are equal to. If I ask you what is the difference between the protons and electrons now, the difference will equal 3 minus 3 will equal, of course, 0. The whole atom doesn't have a charge because the difference here equals 0. And here also 9 minus 9 equals 0. Nothing. At the end, as they are equal to each other, it will equal nothing. Imagine that you take your pocket money from your dad, you take for example 10 reals, but at same time your brother he gave you money before and he needed it back and he gave you 10 reals. So you must give your brother again the money that he needs, okay? Because you owe him this money. So when you give him the 10 reals back, the equal back to you zero, nothing. That's the idea here. When the protons are equal to electrons, the difference of course will equal zero. So let's have a simple game here, okay? Let's try to build our own atom. So I opened the website for a simple game to build our own atom, okay? So let's start. I'll add protons, two protons now, and two electrons. Good. I can add neutrons too. So if you look here closer, you'll find two protons, two neutrons, and two electrons. If I look to the difference in the scale between positive and negative, I'll find it, yes, zero. I have two positive and two negative. Let's think about a simple idea here. What would happen if I add another electron? One more negative, what would happen? Let's see. Yeah, still have two protons here, but three electrons. So actually, I have one more negative charge. Thus now the atom will move more to minus and have -1 charge or -1 charge because I have two protons only, but at the same time 1, 2, 3 electrons. Okay, I will take it out back to zero as two positive, two negative. If the neutrons may be confusing, I'll take them out for now. So I have two negative, two positive, sorry, two negative, and the difference is zero. Okay, so what would happen if I do the opposite? I'll add now a proton with a positive charge, more. Yeah, so now I jump it to +1. I have now one more charge. The element it changed, it turned to lithium, but it's no problem, we'll deal about this later. But what I care about, yeah, I have now three protons, as you can see up there, two electrons, so I am now +1. Let's add another one. +2, +3, +4. Okay, let's stop for a minute. It's now +4. These two are equal to these two, but I have an extra 1, 2, 3, 4 more protons. Okay, I now wanted to turn it back neutral. I want them equal. Shall I add more protons? No, +5, +6. Whoa, that's not right. I want it to turn back to be equal in the middle, the arrow in the middle. Let's try the opposite. Or neutrons first. If I add neutrons, no change, still +6. Neutrons have no charge, so it will not make a difference. See, nothing changed, +6. Okay, let's do the opposite. Let's add electrons. I have now +6. Oh, it's turned to 5. They are decreasing. They are decreasing. Okay. 4, 3. The electrons now are increasing. Let's count how many electrons we need. I think all of these are equal. Protons equal to electrons. I still have 1, 2, 3 protons. So let's add the opposite. 3 electrons. 1, 2, 3. Okay, stop for a minute. Now they are back. 0. They are equal now. If I wanted to turn or have a negative charge, let's add electrons. -1. I have now more electron. -2. Nice game, right? I will send you the link for this simple game to build your own atom, and you try it as much as you can. to build your own stable or neutral atom where the positive are equal to the negative. The difference is 0. Now if we jump it again, 0, 2 and 2, 3 and 3, 4 and 4. So the difference will be always 0. If we back here together, after our simple game, we'll find here, if let's count together, 1, 2, 3 electrons, 1, 2, 3 protons, and we say we don't care about the neutrons for now. Here, let's count the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 electrons, that's correct. Protons, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are right till now. Difference is 0. 9 minus 9 or 3 minus 3, that's 0. We agree on this already. But what would happen in this case? We will lose an electron moving from here to there. What would happen? Would these numbers stay same or different? And the difference or the charge for the atom will stay 0. Of course, now when I have only 2 electrons negative, it will be less than 1, 2, 3 protons. So the difference, as I have 3 protons but only 2 electrons, the difference is 1 positive. On this side, I have only 2 negative, and on the other side, 3 positive. So the difference, I have 1 more positive proton. What about the difference here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 electrons, and inside I still have my 9 protons. 1, 2, 3, 4, 5, 6, 7, 8, and where is the 9? I missed it. Yeah, here it is. 9. So I still have my 9 protons. So 10 electrons negative, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of them have negative charge. While on the other side, I have only 1, 2, 3, 4, 5, 6, 7, 8, 9 positive charges. So the difference is minus 1 now. 1 more minus. Okay? Today's lesson was just simple about the difference between electrons, the negative one, and protons from inside, the positive one. And what would happen to our atom if we lost one electron from one side to the other side, or to the other atom. Thank you all. Your homework, that was the part for today, and your homework will find it in Classera. I hope to see you all of you soon. Goodbye.